Hello, Algebra 2. This is a review of the extra credit problems that I posted for you to do from Chapter 10. So hopefully by this point you've submitted your answers, and this is just you checking your work. So you can use this to help you study for your test coming up. So for number 1, there are a bunch of ways that you could do this problem. Probably the easiest way is if you remember the fact that anything raised to the 0 power is 1. So if you have 4 to the 0, that has to equal 1. So if you think about that, then this exponent of 0 has to equal this exponent of 2x plus 3. And so you could start this off by saying 2x plus 3 is 0 and solving that. So you get 2x is negative 3, divide everything by 2, and x is negative 3/2. So that's one way you could do it. The other way is that you could rewrite it in log form. And so you could say you have a log base 4 of 1 equals 2x plus 3. And then this log base 4 of 1, you could use your change of base formula, and you have log 1 over log 4 equals 2x plus 3. And if you punch that into your calculator, you're going to get 0. And so 0 is 2x plus 3. And then you are back up here, and then you just solve that. And again, you run through the whole thing, and you get x equals negative 3 over 2. So that's number 1. For number 2, the problem we were given is 5 raised to the 3 minus 2x equals 5 to the negative x. So we have an equation where we have the same base, so we can drop our bases, and we have 3 minus 2x equals negative x. So we have an equation with just our exponents. And so then we can get x on one side by itself. So I'll add 2x to both sides, and I'll get 3 equals x, and then that's it, and that's your answer. Moving on to number 3, we have 3 to the 1 minus 2x equals 243. So there are a bunch of ways that you could solve this one again. One of the ways is if you remember that 3 to the 5th power is 243. Some people might remember it, some people might not. Some people have an easier time remembering those exponential powers than others. If you remember that, you can see then that 1 minus 2x has to equal 5, right? And so then you can start off by rewriting the equation where you have 1 minus 2x equals 5, and then you just solve that. So you get negative 2x equals 4, divide both sides by negative 2, and then x equals negative 2, and that's your solution. The other way to solve this, if you don't remember that exponent power, is you can convert it into log form, right? So then I would have log base 3 of 243 equals 1 minus 2x. And then this log base 3 of 243, we can do that with our change of base formula, and we'll have the log of 243 over the log of 3 equals 1 minus 2x. And if you take this log 243 over log 3, plug that into your calculator, you'll get 5 equals 1 minus 2x. So then at that point, you are back up here, and then you run through that process again. So moving on to number 4. Oops. For number 4, we have 10 to the negative 3x times 10 to the x equals 1 over 10. So this is a problem where we could combine everything and rewrite everything in terms of the same base. So the first thing I want to do here, we have two 10s on the left side, and what we can do with those is we can add those exponents, right? I've got a negative 3x and an x. So I can do negative 3x plus x, and that would give me negative 2x. So then on the left side, I would have a 10 raised to the negative 2x. Now, we can take a look at our right side. 1 over 10 is the same thing as 1 over 10 to the 1, which then I can flip that and make my exponent negative, so then this is the same thing as 10 to the negative 1. So then that could become my new right side of the equation. And so I could kick that down here and say that this is now 10 to the negative 1. And so what I have going on now is I have the same base on either side of the equation, and so I can drop my bases and write an equation with just my exponents. So that gives me negative 2x equals negative 1. And I'll divide both sides by negative 2, so then x is a positive 1/2. Going on to number 5, I have 4 to the negative 2x times 4 to the x is 64. So we're going to do this one similarly to how we did number 4. We can start off by adding these exponents because they have the same base. So negative 2x plus x is a negative x. So then my left side of the equation is going to become 4 to the negative x. And then 64, hopefully you remember that 64 is the same thing as 4 cubed. So then we can rewrite the right side of the equation as 4 cubed. And then if we drop our bases, we get the equation negative x is 3. So, but we would really like a positive x, so then we can say that x is negative 3. And that's our answer for number 5. So going on to number 6, we have negative 10 plus log base 3 of n plus 3 equals negative 10. Well, the first thing I can do is take the negative 10 on the left side and move that over. So I'll add 10 to both sides. So now I have log base 3 of n plus 3 is 0. And then what I can do is I can convert this to exponential form. So I have a base of 3 with an exponent of 0 equals my argument, which is n plus 3. Now 3 to the 0 is the same thing as 1, so 1 is n plus 3. And then I can subtract 3 from both sides. So 1 minus 3, we get a negative 2 is n. And so that's our answer to number 6. Moving on to number 7, we have negative 2 log base 5 of 7x is 2. So the first thing I can do here is move that negative 2 over. So I'm going to divide both sides by negative 2, right? And so then on the left side, that'll cancel those negative 2's, and so I'll be left with log base 5 of 7x, and then on the right side, that's going to equal a negative 1. And so now I can convert this to exponential form. So I'll have a base of 5 raised to the negative 1 is 7x. So this 5 to the negative 1, well, that's the same thing as 1 over 5 equals 7x, right? And if I want to get x by itself, well, then I can just multiply both sides by the reciprocal by 1 over 7. I'll do that in a different color to show you. So I multiply both sides by 1 over 7. And so on the right side, that'll cancel my 7's, and I'll be left with just x. And then on the left side, I have 1 over 35. And so that's my answer for number 7. Going on to number 8. So for number 8, I have log base 12 of v squared plus 35 equals log base 12 of negative 12v minus 1. And so what I'll do here, well, I only have one log on either side, so I can clear my logs and rewrite an equation without them. So that'll give me v squared plus 35 is negative 12v minus 1. And so what I'm going to do is I'm going to set this equal to 0. Whoops, somehow I just changed that v to an x. So let's go back and fix that. So I'm going to add 12v, add 12v, add 1. So now I have v squared plus 12v plus 36 is 0. And so then I can factor this. So let's see, v plus something, let's do v plus 6 and v plus 6, right? And so then I set, well, those are the same things, so I only have to set one of them equal to 0 to solve, and I get v is negative 6. And if I go back and check, well, if I were to take this negative 6 and plug it into this first argument here, well, that'll square and it'll be positive, so that'll be okay. And then if I plug it into this argument here, well, a negative times the negative 12, that turns into a positive, so that will also be okay. So your answer for number 8 is going to be negative 6. Going on to number 9. For number 9, I have log base 9 of x plus 6 minus log base 9 of x is log base 9 of 2. And so I have this subtraction between these logs here. So what I can do with that is combine those logs and turn that subtraction into division. So what that'll look like is log base 9 of x plus 6 up top, because that's the positive piece. And then I'll have that lonely x down below because that's part of the negative. And then that equals log base 9 of 2. So now I have one log on either side, so I can drop my logs and rewrite the equation. I'll have x plus 6 over x, and that equals 2 over 1. And so now I can cross multiply, and that will give me x plus 6 equals 2x. And so I'll solve this, and I get 6 is x. And so if I plug that into any of my arguments from the beginning, it works out, and all of the arguments are positive, and so our answer for number 9 is 6. For number 10, we have an expression that we have to evaluate. We have log base 4 of 64. So maybe one of the simplest ways for you to do this is just to plug this into your calculator. This, you can use change of base. So this is log 64 over log 4, and if you do that, your calculator will give you 3. And so for the same thing for 11, we have log base 64 of 4, and you can also turn that into your change of base, and this is going to turn into log 4 over log 64, and that simplifies to 1/3. And so you can plug that into your calculator as well. For number 10, if you don't want to do it in your calculator, you could take this log base 4 of 64, set it equal to x, and then you can convert that to exponential form. So if you convert that to exponential form, you'll have 4 raised to the x is 64. So then at this point, you have to ask yourself, well, what power of 4 gives us 64? And hopefully you remember that 4 to the 3rd is 64. And so then in that case, you would just say x equals 3, and that's another way to get your answer. And so likewise, for number 11, you can run through the same process there. I could have log base 64 of 4 is x. So then I rewrite this in exponential form. I have a base of 64 raised to the x is 4. So now you have a larger number being raised to an exponent equaling a smaller number. And so whenever you run into a situation like this, you know that your exponent is going to have to be negative. And so one of the things that I do that helps me out with this is I can rewrite this as, well, I'm sorry, your exponent won't have to be negative, it'll have to be a fraction. Because you've got to kind of think it's kind of like you're taking some root of 64. And so you ask yourself, well, what root of 64 gives me 4? Right? So you can put 64 inside a root, and if you do a square root, well, that's 8. That's not what I wanted. And then you can try a cube root, and you should know that the cube root of 64 is 4. And so if you have a cube root, well, a cube root is the same thing as having an exponent of 1/3. And so then that's where, so then this exponent of 1/3 is that x right there. And so then that's how you get your answer of 1/3. So you can see I did these problems 2 different ways. Obviously, it's faster to just plug it into your calculator, but if you want to try to do them by hand, that's one way that you can do those by hand. So that's 10 and 11. let's go on to number 12. Let's see. So for number 12, we have log of x over y to the fifth, and we have to expand this. So we have division in our argument, so that means we're going to have subtraction when we go to expand this. So this will turn into log x minus the log of y to the fifth. And then that 5 can come in front as a coefficient, and so then that'll give us log x minus 5 log y. And that's our answer to number 12. For number 13, we have the log of the cube root of x, y, z. So whenever you have a root in a log, you want to turn that root into a fractional exponent. So this is going to turn into the log of x, y, z, all raised to the third power. And then what you can do is you can take this exponent of 1/3 and apply it to each piece in the argument individually. So then this turns into log x to the 1/3, y to the 1/3, and then z to the 1/3. So they all have their own exponent. And so they're all multiplied by each other. So then what you can do is you can separate them with addition. So then we have log x to the 1/3 plus log y to the 1/3 plus log z to the 1/3. And then all of those exponents can go in front and become your coefficients. So then the last step is to write it like that. So then I have 1/3 log x plus 1/3 log y plus 1/3 log z. And that's our answer for 13, and we're all done. For number 14, we have to solve that. So we have e to the x minus 1 minus 5 is 5. So the first thing I want to do is get that e by itself. So I'm going to add 5 to both sides. So then I get e to the x minus 1 is 10. And then to get rid of that e, I can take the natural log of both sides. So remember, the natural log, it's a log with base e. And taking the natural log of anything, well, natural log of e, your answer is just going to be your exponent. So then our next step will have x minus 1 equals the natural log of 10. And so then you could plug natural log of 10 into your calculator. So I do the natural log button, which is on the left side of the calculator, third one up from the bottom. So I do natural log of 10, enter. And so I get x minus 1 is 2.3, we have to round to 4 decimal places. 2.3026. So then I add 1, and I get x is 3.3026, and that's our answer for 14. Going on to 15, I have 9 to the n plus 10 plus 3 is 81. So I'll subtract 3 from both sides. 9 to the n plus 10 is 78. And then at this point, I can convert this to log form. So I have log base 9 of 78 is n plus 10. And then I can use my change of base formula. So I'll have log 78 divided by log 9 is going to be n plus 10. And so log 78 divided by log 9, I can plug that into my calculator. So let's see, log 78, close the parentheses, divided by log 9, close the parentheses, hit enter. So I'll get 1.9886, and that equals n plus 10. So then I subtract 10 from both sides. And so then n is going to be negative 8.0114. And so that is that's going to be our answer for number 15. So I hope that helped, and I hope you answered any questions. You got answers to any questions you might have had from those extra practice and extra credit problems.